Good morning, good evening, everyone. Welcome to our workshop on Metaplex Core, the new innovative NFT standard on Solana blockchain. My name is Vĩ, the DevRel Executive Vietnam, and I'm very excited to have all of you here to explore the groundbreaking technology. To give us a deep dive into technical details of Metaplex Core, I would like to introduce our special guest, Kip, the core engineer from Metaplex. Hey, Kip, can you introduce a bit about yourself?
Yeah, so my name is Keith. I go by Blockosaurus on Twitter. I've been a Metaplex protocol engineer for a little over 2 years now, so I've kind of been there since the beginning. I've seen how NFTs have evolved over time, and we've been like helping out with the new metas, and we've been trying to implement new stuff. And when you work at a small startup, it's kind of like a full stack job anyway. I've built UIs, I've built SDKs, I've built CLIs, so really kind of had my hands on every sort of protocol, and I'm one of the co-designers behind the new core standard.
Oh, yeah, cool. Mm, okay, so hey everyone, if during the event, if you have any question, feel free to put them in the chat, and Kate will answer them in the Q&A section. Okay, so we are ready. Kate, just stay yours. So let's get started.
Sure. Yep, so I'm sharing my screen with the slides.
Yeah.
But yeah, feel free to pop any questions in the chat. Happy to answer as we go. Yeah. So Metaplex Core, I wanted to cover Metaplex Core, its architecture, its general design, and more importantly, share the lessons that we've learned maintaining token metadata. Solana's leading NFT protocol over the past 2 years. We've learned a lot, and I think there's a lot that can be learned and shared with the community for anyone building for mass adoption. There's a lot of lessons here on technical debt and implementation details that you need to keep in mind when you're building for stuff like that. So the first question is really, and to understand the core architecture, you need to see if my screen's lagging. Okay, so really the first question to understand core is like, why does core exist? We've been maintaining and improving token metadata for the past 2 years, or past 3 years at this when we just improve upon it. And you can see kind of some previews on the side here, like, hinting at the answer. You have core, which is a single app. So really, when you look at token, so I guess one thing is like, a lot of the reference is like who's worked with token metadata in the past, who's worked with core already, who's worked with like token extensions, because a lot of that kind of will help inform some of the differences. And there's a lot of, really the best way to explain new things is generally in the context of old things. So I'll be referencing token metadata and token extensions a lot in this presentation. But yeah, when it comes down to it, if you look at token metadata, if you worked with it before in the past, it has just a huge amount of accounts that you need to pass in anything. Solana has been limited in transaction size to 1232 bytes since its inception. And that with 32 bytes per account, that really diminishes over time as you build more composable solutions, as you build protocols. Every account matters that you have to pass in, because every account cuts into the space you can use for your own stuff. And really what this means is token metadata itself is not very composable. Token metadata was created, for those who don't know, as an artist protocol. It worked with the original Metaplex protocol, which was actually a storefront that was used for printing out editions and making art. So every token metadata NFT has its own master edition, which was originally intended to print off editions, kind of the way current art marketplaces do. But that's now rolled into every single NFT. That's kind of a core fundamental thing of the design. And so every NFT requires this extra account, even if you're not using editions. Likewise, it's built off of SPL token, which means that in addition to all of the metadata, you also need the mint account, which is a separate account. You have a token account, which is also a separate account that's used for fungibles. And really, token metadata is just trying to do a lot of things at the same time. It's trying to support master editions. It's trying to support fungibles. We added just a year and a half ago, the programmable non-fungible standard, which adds a bunch more accounts. There's, the token record for programmability. There's a rules account that blocks malicious marketplaces from not enforcing royalties. There's a couple extra programs that it now needs a CPI into. And this just really adds up over time. Additionally, another thing that when you're designing for mass adoption or building stuff that users are using, you're not integrating with your own tools, is backwards compatibility is important. You can't just break backwards compatibility when other people rely on your standards, because then other people's stuff is not going to work. And, that kind of erodes the trust over time. We're pretty proud of the fact that we follow semantic versioning, which means we're very clear about when there's a breaking change. I think for the most part, every breaking change we've made or tried to make has not broken anyone. We have like one or two cases that slip through the cracks. But in general, our target is to never have anyone be able to point to us as a source of blame for breaking their protocols. We even work with people to try and explain. When we implemented PNFTs and PNFT migration, which was a large breaking change, we had a giant working group trying to get every single protocol on board. We didn't flip the switch until a majority had done that, because backwards compatibility is really key for any sort of mass adopted protocol. But also this works against us. When we're trying to improve token metadata, there's a lot of things we could do. We could get rid of master edition accounts. We could get rid of the reliance on SPL token possibly. But then that introduces a huge breakage that everyone needs to deal with. And that's something that, this is kind of was something that was just too big to swallow. And sometimes the best answer to addressing technical debt is just burning it down and starting from scratch, so to speak. And that's the path we chose to do with Core. And as people who have been in the space for the past year now, a bunch of other standards have been popping up. There's WNS, there's Token 22 or token extensions. And the question is, why not build on those? Why build Core, which is its own new program, isn't relying on an SPL token? What's the reasoning for that? So one of the things we learned with PNFTs is the fact that the reliance on SPL token is kind of a double-edged sword. It's great because integration is very easy. It's easy to build on top of. There's really broad support because token extensions is backwards compatible with the original SPL token protocol. But on the downside, it also means that you're now reliant on someone else for integration work. As we saw with PNFTs, we had to add an extra token record account to store programmable data. We didn't have strict control over transfer operations, so to block malicious transfers, we couldn't hook directly into the SPL token program. We had to kind of do this very messy freeze, unfreeze, and transfer stuff for checks. Additionally, SPL token, the protocol is designed for fungible tokens. Every single SPL token has its own corresponding token accounts, which signify the balance that is held by someone. So a token account is just a PDA of the owner and the token mint. But that balance is always going to be one for NFTs. There's no reason to have a token account. Why store that data if it's only ever going to be one? So really, the target with Core was to build something that's very good at being an NFT protocol and, focus on that sole thing and make it very easy to work with. So by not building on SPL token, we could, issue the ATAs and any sort of reliance on an external program. You no longer need to pass that program in, and you can really just work with a single account, which really optimizes and allows it to be space and rent efficient. Because for people who don't know, every new account you add to a transaction, every account that you pay for in rent, not only has the data that you include, but also has 128 bytes of overhead, which is about 90,000 LAN ports. That adds up over time. So by doing this, we can kind of reduce the general cost. A token metadata NFT is like 0.02 SOL, I believe. And with Core, we could reduce that down to 0.003 or so. So when designing a new standard, where do we start? How do we do this? And the answer is really just to give token metadata and the stuff we've learned there a big haircut. The idea is to shave off all the extra stuff that's been added over time, all the organically grown features that not everyone uses, and really optimize. Like the key starting point is boiling down an NFT to its common components. In the past 3 years, watching the NFT space on Solana and other chains, what is an NFT? What does it mean? What does it represent? And really, you can cut that down to a proof of ownership and an asset. So as far as NFTs go, the couple things that haven't changed are the fact that someone owns an NFT. So it's kind of a provenance proof that someone owns an asset, and an asset itself, which just means it has a name and it has a URI. That's all that it represents. It can be named and it can point to some off-chain data. Likewise, you need to define what an NFT can do. What are the core lifecycle events, as we call them, that represent an NFT and its functionality? So you can create it, obviously. You can destroy it, which is burning a token. Ownership can be changed, whether or not you're trading it, you're lending it, you're renting it out, or you're listing on a marketplace. That's a change of ownership. So that all boils down to the same thing, and then it can be mutated. I've helped launch a couple NFT projects and managed a couple. And the first project I launched, we messed up our URIs pretty badly. So we were there the day of mint, editing the URIs on the fly, and that's just kind of a mutation, like updating the data. Whether it be typos, adding new features, adding new functionality, or data fields, that's just a mutation on the asset. So another thing that we learned over time was that collections are important. So token metadata added NFT collections about a year into its lifetime. It's just an additional field on the metadata account that points to an external mint. But really all it is just a little bit of data that's appended on. We wanted to turn for core collections into a first-party feature. So what this means is that the collection is now kind of inherent in the design rather than just tacked on for other standards, or like it is for other standards. So, the first meaning of that is a collection authority is the authority of the collection. Now, that sounds confusing, but really what that means is if I am the manager of a collection and I have a collection object on chain of which I am the update authority, I should be able to operate on the entire collection. If you've ever derugged a collection or your wallet has been compromised and you've needed to migrate it over to a new update authority, that's trying to land, thousands of transactions on chain because each NFT then needs to be updated to point to a new authority. So for like a standard 10K PFP collection, that's 10,000 transactions, which was hard to land even before Solana congestion issues. Try doing that today, and it's almost impossible. So really the answer to that is why not make it a collection-wide state? Like why not have that something that's inherited by every NFT? Why? So now with core, the collection is actually its own type of update authority, where if you are the update authority of a collection, that's one transaction to change the update authority. That's one transaction to do any of those sort of standard migrations. You're no longer operating that on every asset and duplicating that code. Likewise, we wanted to take this, use an inheritance model. A lot of us at Metaplex are object-oriented programmers, and we wanted to kind of apply this because, what is an asset or an NFT if not an object? So what we did is we made it so that data can be inherited. So if I wanted to set collection-wide attributes or, royalty data or anything like that, each asset can inherit that data itself. So when I'm setting royalties on a collection, I only need to set that once. If I want to change it from 5% to 4%, that's a single transaction. And, marketplaces know that when they're trading in assets, they should look at the collection itself for the royalties and utilize that data instead of, only looking at the asset itself. Likewise, behavior and plugins, which we'll talk about later, which are hook into lifecycle events like create, burn, etc. All that behavior is also inherited, polymorphically. So if I wanted to add royalty enforcement to my collection, again, that's something I only need to add to the collection itself. That behavior will be inherited by the assets. So if I'm trying to block malicious marketplaces or anything like that, or I want to block, a rug protocol, I can set that on the collection itself. The asset will know to obey the collection's behavior. and that can all be passed down. And you're not duplicating that data. We have programmable configs on like NFT collections on token metadata, and that programmable config, while identical, is still duplicated every single time, and you're paying rent for all of that. You're paying, all the complexity for all of that, and that's no longer necessary on core. But much like object-oriented programming, you can also possibly customize using polymorphic behavior. So if I wanted to override the base behavior or override the base data, it's also possible to do that by setting it on the asset itself. So for example, if I wanted one asset in a collection that has much higher or lower royalties, that's easy to do. You just set it on the asset, and marketplaces will know to rely on the asset over the collection. So really, when you do all that optimization, when you boil everything down, when you reduce an NFT to its core components, you end up with a core asset, which is represented here. So you have a key, which is used for internal management. That's just an account discriminator for those familiar. Someone owns the asset. Someone has the permission to update the asset. So this can be a collection. This can be a pub key. This could be no one for immutable stuff. It has a name, and it has a URI. And likewise, as far as creating an asset goes, it can be boiled down to a simple instruction. We have very reasonable defaults in the SDK. So this will, by default, be minted to the person, the identity key pair on UMI. And really, I will need to pass in 3 arguments. I can pass in the asset pub key, which is used for creating the account. I'm passing in a name, and I'm passing in the URI. And that's core boiled down. But we're not quite done. Because building for 90% of use cases means that you also need to allow people to build additional functionality. We ripped out all the stuff that that every single person doesn't use. Not everyone wants royalty enforcement, so that's not included in the core protocol. Not everyone, or the fundamental structure, not everyone wants, attributes on chain, and so that's not included in the core structure. But we also want to allow people to build whatever they want and customize. Some people do want that, which means we need to support that. And the idea is to build flexible solutions that allow people to customize however they want. This is kind of an a la carte method. If I'm in a shopping aisle, if I go to the Metaplex core plugin store, I want to be able to pick and choose the behaviors I want. I want to be able to pick and choose the data that I want to store. But if I don't need something, shouldn't have to pay for it. And I think this is one of our biggest learnings from token metadata, is the fact that when you hard code behavior, you just have to pay for it. You can see that with master editions. Not everyone, barely anyone uses, art or art printing by volume. And so people who aren't using that shouldn't have to pay for master editions. But it should be an option down the line. We see token extensions, or token 22, hinting at some of this. They have the cool extension concept where at mint time you're allowed to add token extensions. You're allowed to add extra data or metadata or stuff like that. But we wanted to take that to the next level. And that's where plugins come in. So anyone who's familiar with software development knows what a plugin is. A Chrome extension is really a plugin. A VS Code extension is really a plugin. They're dynamic little software packages that you can inject into your main framework and execute optionally to allow people to customize however they want. And that's something we wanted to bring on chain. So really a plugin operates much like an app on your phone. You can go to a plugin store or whatever, or go to the configurator, and you can add plugins or remove plugins as you desire. If I want to add this as a creator, I can just add the attributes plugin later. So they're really kind of more dynamic than the concept of extensions. It's not just a mint time operation. You can add or remove these whenever. But the balance of that is you don't want a creator to be able to assume more power than they've been given. You don't want to accidentally have them rug users by, adding crazy stuff, or they don't want to delegate permissions to, a malicious protocol accidentally. So that's another thing we adopted from the mobile phone programming model is permissions. So, for example, when you go to your phone, if you download Facebook or something, it'll say this app wants permission to, access your camera, access your address, steal your identity, yada, yada, yada. And we wanted to, carry some of that over. So now plugins have permission to do certain things. So plugins operate by blocking or approving lifecycle events. So for example, transfer, burn, create, update, all those. And a plugin has permission to block or allow things. So if a creator is adding an attribute plugin, it'll say this plugin requires no lifecycle permissions. If a user is adding a transfer delegate plugin, it'll say this plugin will now have permission to transfer the asset on your behalf, and that's something you should know about. And you can choose clearly whether or not to approve or deny that. Additionally, plugins have authorities, so authorities are pretty well segmented. Kind of in the file system model, where different users different plugins are treated as different users, and they all have permission over their own data but nothing else. Something that inspired this was the immutability working group for MonkeyDAO, which I'm on, where we talked about how MonkeyDAO wanted to make the data immutable to guarantee that nothing could be modified. You can't accidentally rug and change the pictures of all the SMBs to something. But they wanted to be able to slowly wind down royalties over time as the DAO became less reliant on that income model. But this isn't really possible on token metadata. They're standard because it's all or nothing immutability. You set a flag and everything's immutable, and so that would also mean royalties are immutable and can't be wound down. So that's something we wanted to modify with Core. So now immutability and royalties are separate. You can make things immutable on a plugin by plugin basis. So if MonkeyDAO were built onto the Core standard, they would be able to mark the data as immutable and all the plugins as immutable, but leave royalties mutable, so those could be wound down over time. We just think that's a really powerful model that allow, immutability guarantees without compromising behavior. So there are 3 classes of plugins as we define them by different types of permissions. There are owner-managed plugins, authority-managed plugins, and permanent plugins. Owner-managed plugins are most akin to the app model, where an owner of asset has certain permissions. An owner of an asset is allowed to transfer it. They're allowed to burn it if they so choose. But as we've seen with SPL tokens, they should be able to delegate this behavior as well. Say I'm listing on Sniper, which is an escrowless marketplace. I give Sniper, freeze permission. I give Sniper transfer permission. So if a sale happens, they're allowed to transfer it on my behalf. With something like Burger Game or Squid Game on chain, you should be able to delegate the burn behavior as well to give it permission to burn the asset. That's really what an owner managed plugin is. You take user operations and you can delegate behavior for that. We also see future owner managed plugins for special data fields, which could also be useful. Authority managed plugins are more like extra key value data that can be added to an asset. So royalties is an authority managed plugin. I'm the update authority. I want to add royalties to my asset. I'm permitted to do that by adding that plugin. We have attributes, we have additions, all that sort of stuff. And again, all that can be delegated. So I can delegate the addition permission to a candy machine that prints off additions from a master. And we also lock the NFT logged into the game. Yeah, so all this is delegatable. So you could, there's a freeze plugin, which is an owner manager plugin, which would give permission over the game to freeze the plugin. But yeah. And then lastly is permanent plugins. So this is more akin to token extensions. If you're familiar with that, they're permanent authority. Say I'm minting a collection of subscription NFTs. I want to be able to pull those back if you don't pay your subscription fees. I should be able to transfer that back to myself and kind of claw that back. Or for legal compliance, sometimes you need to claw back assets, and that's where permanent plugins come in. They're kind of like a medium between owner-managed plugins and authority-managed plugins, where the authority is allowed to gain permission over some certain ownership lifecycle events like burn and transfer that it wouldn't normally have permission over to. But we also want to, keep the balance between owner power and authority power. So permanent plugins are only settable at mint time. So when an owner mints an NFT, they know what they're going to get. If there's a permanent plugin set, that'll be set at create time, and they know that when they're signing off another transaction. So the authority can't, gain additional permission without the owner's consent. waiting for my Chrome. Here we go. So let's go through an example use case. Here we have setting a transfer delegate, and all this code is available on our docs for reference, which I'll have a link at the end. So if I'm setting a transfer delegate as the owner, I'm basically adding a plugin that is the transfer delegate plugin, and the authority up here is going to be the init authority, which is just the delegate pub key. It's a simple transaction. I can do a lot of these behaviors. This is really 3 steps. This is, I create the asset above, I add a plugin that's transfer delegate, and then I delegate the transfer delegate permission to this pub key here. But all this can be done in a single SDK function. We've worked pretty hard to make the SDK as usable as possible and as clear as possible. So you can kind of do a lot of this behavior in bulk. And here down in the assert statement, you can see kind of what the data representation is. We're trying to optimize this for DOS integration and viewability. So you can see transfer delegate is just a field. All the plugins will just be fields on the asset here. And it points to the address that is the delegate. And you can see down here the Rust implementation. This is what the actual protocol implements. There's no actual state stored in the plugin. State is totally optional. Some plugins are stateless. They only have an authority, which is kind of built into the core protocol. So it doesn't actually need any additional data. And this is a owner managed plugin. So only settable by the owner. Next, we have an authority managed plugin, which is enforcement of royalties. So this is a little more complicated. As you can see in the bottom, royalties has state. It uses a creators array to know who to pay royalties to, percentage of royalties to actually pay, and a rule set for, blocking or allowing specific marketplaces. And you can see on the right-hand side how this is represented in the SDK. I'm creating an asset, and I just have to pass in the data when I create it, the basis points, the creators array, who to pay the royalties to, and then a deny list with, who's blocked. SPL token here is just an example test, but I can add like a malicious marketplace here. And so during a transfer event, the way this works is the program, the royalties plugin has permission to deny a transfer. So it has the ability to reject a transfer lifecycle event, which really just means it's going to go in when I, as the owner, click transfer on my asset to list it on a marketplace. If the royalties plugin will check, it will check where I'm transferring it. If it sees a malicious marketplace here in the array, and then I'm trying to transfer to a malicious marketplace, it'll reject that, and that operation will no longer go through. And that's really kind of how plugins work, is through rejecting or approving permissions. But wait, still not the end. So as I mentioned above, one of the frustrating things about working with programs on Solana, Solana has a very different programming model than Ethereum. With Ethereum, you're deploying an NFT collection, you're deploying a whole new contract, you can add custom behavior, you can do all that. Now, Solana's programming model is more ownership-based, so programs own all the accounts that they manage. So you don't see the same sort of thing here, where people are deploying new contracts. You see them reusing the same contracts. People have kind of congregated around 1 or 2 NFT standards to mint on, but also we don't want, so like people will be using core to actually mint NFTs and mint NFT collections, but it's going to be really frustrating if you have, every time you want to add custom behavior, you have to either build a new program or go to us. I don't want that. Users don't want that. People want to be able to customize their NFTs however they desire. And we want to kind of implement the first concept of interfaces for mass adoption, where people can hook into assets however they want. So we've created what we like to call external plugins, where users can hook in customized logic for any sort of, and build any sort of plugin that they want that hooks into their account or hooks into their assets. So we have 3 types here, but we have much more, we've been thinking about and hoping to implement in the future, but the 3 types that will be available in the next couple of weeks, being delivered to DevNet, are Oracle, which is already on DevNet, secure data store and lifecycle hooks. Oracle is probably the simplest one. It's really designed for Web 2 use cases where people who aren't that familiar with Web 3, want to be able to like manage assets dynamically by just setting a value on chain. Really all it is an external account that has a little bit of data that says whether or not a lifecycle event is rejected. So if I wanted to globally freeze my entire collection with an oracle, based on another account, I would be able to do that here. Basically, I just say freeze is disallowed in my oracle account, and that's it. Every time I try and transfer an asset in that collection with the oracle, the program will reach out to the oracle account, check its value, see that transfer is disabled, and will reject that. Next is the one that I'm pretty excited about, is secure data store. So again, like file system, plugin is just like a section of data that's allowed to be written to by the plugin itself, but we wanted to enable that for third parties. A couple of years ago, I helped implement the Fusion protocol, which is like a composable NFT system, where we had like customized, state data that was attached to an NFT as a PDA. PDAs are great and all, and they're a little difficult to work with. And management is something that's hard in data availability. So like if I'm building a custom protocol and want to design a bunch of PDAs, I need to reach out to all the wallets and say, hey, I would like to display this data in your wallet. They need to integrate that. They need to, and that, that kind of isn't a scalable solution. As more and more PDAs become attached to NFTs, that's more data that wallets need to integrate with. So really, what I think is the true answer to this is, well, PDAs are great. Why not store data on the asset itself? Why not turn the data or the asset into its own data store? So wallets and marketplaces and integrators no longer need to reach out to all these PDAs to index this data and display it. They can just read the asset. And that's where secure data store comes in. You basically give external programs or people or anything permission to write directly to the asset itself in a very secure, very restricted sense, where they can only write to the data over which they're delegated. So, they only have permission to write. I think it's right now the restriction is up to 10K of data, and they're not allowed to overwrite any of the other plugins, only the plugin they've been allowed. So the example we kind of used for this is like, say you have a marketplace who wants to award points and they want to set a points multiplier for hotly traded NFTs. So if my DGOD or whatever is trading like, 10 times per hour on Magic Eden, I want to be able to increase the multiplier because it's really hotly traded. So I can write that data directly to the NFT. I no longer need to manage my own PDAs. I no longer need to index a new program or run a new program. Aside from my core contract, I can just write that data there, and everyone, DOS and Magic Eden and whatever marketplace is implementing it will get that data for free by just reading the asset. That's secure data store. And lastly, lifecycle hooks, which is kind of just our riff on transfer hooks, if you're familiar with those, is the ability to trigger events based on certain lifecycle events happening. So, it's not just where transfer hooks, where it's called on a transfer. We're CPIing into programs on a create, on a transfer, on a burn, on an update. And this way you can have really powerful trigger behavior. Some tool I've always liked to work with for IoT stuff is IFTTT, which is just if this, then that. It's an automation protocol where, if this event happens, I want to trigger another event. And we kind of wanted to pull that into the NFT ecosystem by having lifecycle hooks. So now when I'm transferring an asset, I can trigger like a counter that says how many times that event has occurred. I can count the number of transfers. I can count the number of creates on an asset or the number of burns for some sort of burn mechanic game, and stuff like that. And lifecycle hooks also do have permission to reject or approve certain transfers. So this is really the powerful way in which you can add additional logic. So say you wanted some sort of super delegate power, you could write a lifecycle hook that would be able to approve, transfers or other operations on the fly. And for anyone who's interested in playing with Core, we've created this really good reference UI that allows you to configure, feel free to go here, mint some new assets, available on DevNet mainnet. It's really easy to use. Our engineer, Nyan, has done a really great job designing this, where you kind of pass an asset name, you pass in some URI, and you can kind of configure it however you want. you want to make a sold down plugin that will automatically choose which plugins to add. To do that, you can mint collections. And then also in the top right here, we have this Explorer. This is before we had full Explorer support. Solana FM and SoulScan, I believe, are the ones who have support now, which is really great, but we provided a reference UI. For anyone integrating, you can look at your assets, you can look at what plugins are enabled, you can look at what assets in a collection. This is a pretty handy full management console. And it's all open source. The link to the GitHub is on the page itself. There's some nice blurbs of data of how core is powerful, and you can take a look at the code if you want to build your own UI. And then lastly, the core docs. Our community devs have done a great job building these out. These are all available at launch. It has really good documentation of, there's example code, there's pretty much anything you could need. We have some integration guides that are going to be released soon. I'm a wallet and I want to integrate core. I'm a marketplace and I want to integrate core, how to do that kind of stuff. Say I want to build a game, that should all be available there. And then there's some really detailed documentation of the plugins, because we know plugins are a new and kind of confusing concept. So we have tried to do a really good job documenting how those work and what you should expect. And again, if you have any issues reading the docs or questions or comments or anything like that, feel free to hop into the Discord. Provide feedback, provide commentary. We're always, open to hearing that and trying to improve. And that truly is the end. Yep, so that's Metaplex core. Feel free to take a look at the example code if anyone has any questions as well.
Yeah.
Happy to take those now.
Yeah, thank you. Everybody, feel free to ask any questions. Okay, I have a question. So, okay, now we have Metaplex core. So, what is your future of token metadata? Will your core repair it in the future?
Yeah, so token metadata is still being maintained, but I think as we indicated about a year ago, the goal is eventually to make that immutable. I think token metadata will kind of always have a place as the original NFT program. People will still be able to or want to mint on that, for the provenance, for the, the ability, or the kind of the history behind that. We're seeing a lot of token metadata mints right now, but I think for the most part, it's only going to be slowly maintained. We're going to optimize. We improved compute last week, I think, but it should be immutable soon, in which case it'll still be totally functional, but core will be the main focus.
Yeah, okay. Okay, I also have a question. Do we have any marketplace just support Metaplex core right now?
You have what?
I mean, do we have any marketplace just support core right now? For example,
Tensor has full core support, and Sniper as well.
Tensor and Sniper. Okay. Yeah, I see.
And I think Magic Eden has indicated they're going to add support next month or this month.
Wow, yeah, cool.
Yeah, and another thing I guess that I didn't talk about is DOS is fully supported at launch. Soulflare fully supports it. I think we're working on a compatibility page as well for our docs that should indicate who supported it. But Soulflare has full support. Phantom only shows, and DOS indexing is right there if you need it.
Yeah. Okay. So do we need to buy any code to using core?
Sorry, can you say that again?
Are there any costs associated with using core?
So the standard cost for core, I think it's like 0.001 or so in rent, and then there's a mint fee of 0.0015, which is about 10 times less than the token metadata fee. But yeah, there's still a fee that isn't refundable when you burn it, but that mostly just funds the protocol and funds DAO grants and stuff like that. So it goes back into the foundation, which is then used to support the community.
Yeah. Okay, I see. One more question from me. Uh, so, what is the difference between pay-as-skin and internal pay-as-skin? Uh, can we, as a developer, can we create can I create my own pay-as-skin for your code?
Wait, your own plugin?
Yeah. Can I create for myself a pay-as-skin for the core NFT?
Yeah, so right now Oracle's the only one available on DevNet. Secure Store should be so those are all plugin adapters, which will allow you to create your own plugin. That should be available very soon, within the next week or two. But yeah, then you'll totally be able to go crazy. We'll have hopefully YouTube videos and like content and tutorials and everything for creating your own plugin. So very soon.
PK had.
Yeah, and I think. Oh, sorry. Go ahead.
Yeah. Okay, keep going.
Yeah, I was gonna say. Yeah, we expect wallets to have. Soulflare has full support. Phantom is indicated within the next month. They wanted to have support. Not too sure about squads. Backpack has display support because they use DOS directly. We're talking with them right now about getting transfer support as well.
Yeah. And I also see attribute pay-as-skin. Do you have any UK for this pay-as-skin?
A UI for plugins?
I mean attribute pay-as-skin. I say attribute pay-as-skin. Do you have any UK for that?
Sorry, I still can't quite get what you're saying. Oh, do I have any questions?
Yeah, I can.
Oh, sorry. Yeah, attribute plugin. We've had marketplaces asking for a while about putting traits and stuff on chain. Right now, if you look at like Tensor and Magic Eden trait-based bids, I want to bid on a Bandito monkey or something. That all has to be done through Web 2 because all that data is stored off chain. This would kind of allow them to bring that on chain as well. But generally, attributes are kind of useful for any sort of metadata you want to supply that you want to use in your contract. So say I wanted to make like a sombrero staking contract where only monkeys with sombreros were allowed to stake. I would use it something like that for that.
Yeah. Okay, I see. Okay, let's see some. Do any people have any question? Yeah, I think. Yeah, PK have another question.
None of the plugins are mandatory. They're all optionally added. If you don't want it, you don't have to use it. I think Secure Store will be even more powerful for that. Attribute plugins is kind of like a stopgap as we add external plugin support for that, where you'll be able to store data in a much more compact representation. You can store the straight binary if you want. If you want DOS support, you can use Message Pack, which is still small, and you'll get indexing for free.
Yeah, cool.
Awesome.
Okay, so okay, I think there are no more questions. So if you guys have any question, feel free to send Kip and or me a DM. We will try to answer them after the workshop. And thank you, Kip, for joining us today. It's very informative.
No, thank you for having me.
Yeah. We hope to see you again in the future workshops. Yeah. Thank you, Kip, and thank you for everyone. Have a nice weekend.
You too.